Experts Guidance.
For class 10 students, the topics covered will be chemical bonding, circulation, volume and surface area, electricity and magnetism.
And for class 12 students, the topics covered will be principles of inheritance, solutions, continuity, differentiability and higher order derivatives, and modern physics.
Time is ticking. Enroll right now.
Surprises are waiting for you.
Hello students. Bookmarks Educare is offering you a free webinar on 25th and 26th October for upcoming board exams.
Boost your preparation in physics, chemistry, maths and biology with Experts Guidance.
For class 10 students, the topics covered will be chemical bonding, circulation, volume and surface area, electricity and magnetism.
And for class 12 students, the topics covered will be principles of inheritance, solutions, continuity, differentiability and higher order derivatives, and modern physics.
Time is ticking. Enroll right now.
Surprises are waiting for you.
continuity and differentiability are fundamental in calculus. So, continuity and differentiability are fundamental in calculus, fundamental concept in calculus. So, now I will discuss what is continuity. Continuity means a graph, a function, so continuity means a function graph can be drawn without lifting pen. So if you draw a graph, then without lifting pen from paper, that will be that particular graph will be said continuous. So a function is said to be continuous at any particular point, say C or A, whatever it may be, when if and only if right hand side limit of the function, left hand side limit of the function, and the value at that point, function of the value of the function at that particular point should be equal. So say x is equal to A, right hand side limit of the function is equal to left hand side limit of the function is equal to f of A. If any function obeys this condition, then that particular function will be said continuous at the given point. Here is the point is x is equal to a. So now if the function does not obey any condition from this, that type of function, that particular function will said to be discontinuous at the given point. So if the function fails to obey this condition, though that particular function will be said discontinuous at the given point. Now I am going to discuss about differentiation. So differentiability means a function's graph has always unique and non-vertical tangent line at that particular point. That is meant it must have well-defined slope at every point, at every point. So the function must have well-defined slope or derivative at the every point, every given point on the graph. So now a function is said to be differentiable at given point if and only if so at the point x is equal to a, if f dash c, f dash a, sorry, f dash a exists. Derivative f dash a exists, and it is written, or it can be represented, f dash a is equal to limit h tends to 0 f of a plus h minus f of a by h. This is known as first principle of derivatives. So the process of finding derivatives known as differentiation. So next topic is introduction to second order derivative. What is second order derivative? What is second order derivative? Second order differentiation is the process of taking process of taking derivative in the first order of the first order derivative of the given function. So second order differentiation is the process of taking derivative of the first order derivative of the given function, or the differentiation of the first order derivative of the function. So it is written as, or it can be represented, f double dash x d2y dx2 while second order derivative indicate indicate while the second order derivative indicates the change of the slope. Second order derivative indicates the changes of slope, as first order derivative indicates rate of change of the function, and second order derivative indicates the rate of change of slope. second order derivative provides the information. Second order derivative provides the information of the about the concavity of the function or function's concavity. Second order, what second order derivative provide us? What type of information that second order derivative gives us? So second order derivative provide the information about the function's concavity. It is used to find, and second order derivative is used to find local maximum value or local maxima, local minima value, and inflection point. So that will be discussed later. This is the basic application of derivative. So derivative also used in physics. So to find out acceleration, velocity, to find out velocity we need first order derivative, as well as to find out acceleration we need second order derivative, and going on. So now, before going to sum, I will prove some formula with the help of first principle. So what was the first principle that we have learned? The first principle of differentiation at the given point. Suppose the point, let us assume the point be A. So we have to check differentiability or differentiation at that particular point. So I have to write first principle of derivative. So f dash A is equal to limit h tends to 0 f of A plus h minus f of A by h. So I am going to find out the derivative of x. So how it can be found out? So dd x of cos x, and this can be done with the help of, this can be found out, this can be defined from the first principle of derivative. So now the function is y is equal to f of x is equal to cos x. Here the trigonometric function is 2x. So I am going to find out the formula of 2x. At any point, cos 2x, derivative of cos 2x at any point of x. So ddx of cos 2x. So I am applying first principle of derivative. Limit h tends to 0. So cos of 2 into x plus h minus cos 2x by h. So the function f of x is equal to cos. The function was f of x is equal to, the given function was f of x is equal to cos 2x. So x is replaced by x plus h. So that will be 2x plus 2h. So that is written over here. So limit h tends to 0. See, I am going to apply the formula of cos C minus cos D. So cos C minus cos D, the formula of cos C minus cos D is equal to 2 sin C plus D by 2 into sin D minus C by 2. So this formula will be used here into sin C plus D. C matlab this one and D matlab 2x. So 2x plus 2h plus sin C plus D by 2 into sin of D minus D means 2x minus 2x minus 2h. So 2x will be eliminated by 2 by h. So limit h tends to 0, 2 into sine 4x h by 2 into sine of minus h. 2 also eliminated from denominator and numerator. So sine of minus h by h. So limit h tends to 0, 2 constant. So I am taking it before the limit. Sine x. So 2 also eliminated. If we take 2 from the numerator, that will be eliminated because 2 is present in the denominator. So sine of minus h means minus sine h by 2. So it can be splitted due to the properties of limit. So limit h tends to 0. Sorry, over here h. So minus 2 limit h tends to 0 sin h by h into limit h tends to 0 sin of 2x plus h. So from properties of limit, this function or more than function, more than 2 functions or more than 1 function, whatever it may be. So more than 1 function, limit x tends to a f of x into g of x is equal to, can be written, limit x tends to a limit extension of function this into limit of function g of x. So I use this over here. This property is used in this line. So this is the standard formula of limit. Instead of limit h tends to 0, sin h by h means 1. So and I am putting value 0 instead of x. So minus 2 into sine, sorry, not x, h. Because x over here is constant, x is treated as constant. So value of h is 0. So sine 2x. 0 plus 2x means 2x. So this is the required answer, and this has been proved from the first principle of derivative, and the function was cos 2x. So this is a sum on continuity, discontinuity. So discuss the continuity of the given function where intervals are given. So how can it be proved? How can it be solved? So first of all, I rewrite this function as minus x minus 1 for minus x minus 1 for x less than minus 2. X plus 3 for x greater than equal minus 2 less than 0. X square 3 for x greater than equal 0 less than 3. X cube minus 15 for x greater than 3. So in this sum we can see two intervals. Number one interval, this interval can be written as minus infinity to minus 2. This interval minus 2 to 0, 0 to 3, and 3 to infinity. So as we see, the function f of x is defined as a polynomial in each of 4 intervals. So the function is well defined polynomial function in each of 4 intervals. So in the given function is also continuous. the given function is also continuous. The given function is also continuous in each of in interval. So at the point I have to check continuity at the point -2. At the point -2. So for checking continuity, what we have learned before, ना हम लोग क्या सीखा? कंटिन्यूटी का मतलब राइट हैंड साइड लिमिट ऑफ द फंक्शन equals to left hand limit of the function is equal to value of the function at that particular given point. So at x is equal to -2, limit x tends to -2 minus left hand side limit of function, that is limit x tends to -2 minus x, the function will be -x -1. So -1, so 1. Right hand side limit at the point -2 of the given function. So limit x tends to -2 plus is equal to limit x tends to -2 plus, which function will be taken? This function. So this function will be taken because x greater than equal -2. Minus 2x plus 3. So the value of the function, the limiting value of the given function is -2 into 2 plus 3. So -4 plus 3 is equal to -1. And I have to find out the value of the given function of this function at the point x is equal to -2. So f of x is equal to 2x plus 3 when x is equal to -2. So f of -2 is equal to -4 plus 3 is equal to -1. So since limit x tends to -2 minus f of x not is equal to limit right hand side limit of the given function, so that is why at the point x is equal to -2 the function will be discontinuous. So now I have to check continuity at the point x is equal to 0. At the point x is equal to 0, and the interval this and this. So I have to check continuity. I have to take continuity of the given function of the functions at the point x is equal to 0. So in same way, so I have to find out. I am finding out continuity. I am checking whether it is continuous, whether the function is continuous or not. Same way that we have done previous. So right hand side limit x tends to 0 plus f of x. So x greater than 0 means I have to take this function. For x greater than 0 means right hand side limit. For right hand side limit 0 should be taken this function. So limit x tends to 0 plus x squared plus 3 0 point where the function is continuous. Now I have to check the continuity of the given function at the point 3. Point 3. In the same manner, we can proceed. So limit, right hand side limit at the point x is equal to 3. So x tends to 3 plus. Then when x greater than 3, 3 plus means right hand side limit x tends to 3 plus means right hand side limit means the value of x approaches to 3 from the greater value than 3. So this function will be taken for this is equal to limit x tends to 3 plus the function is x cube minus 13. So 3 will be put over here. So 3 cube minus 15, 27 minus 15. So 2, 1. So left hand side limit of 3 of the given function. So x tends to 3 minus f of x. When x less than 3, then the function will be taken, this function will be taken for for x less than 3. X square plus 3. So 3 square plus 3 is equal to 9 plus 3 is equal to 12. And the value of the function at 3, so 3 cube minus 15 is equal to 12. So these three values are same. That is why we can say the function is continuous at the point x is equal to 3. Now I have to check again the continuity. Oh, sorry. That's all. That's all for this sum. So it is this function is continuous at 0, 3. So this function is continuous, will be continuous at every interval or every point in the given interval except minus 2. Except minus 2. So now I'm going to be off screen for few seconds, or sorry, few minutes, and students also are given few sums to solve. So this sum is based on continuity. Please solve this sum. I'm coming back very soon.
Hello.
Students who solve this question, please match the answer with my answer. So I have to check continuity of the function where the intervals are given x greater than 0, x greater than equal 0, lesser than equal 1, x greater than 1, less than equal 2. So interval is 0, comma 2. So 1 is the breach number. 1 is the breach number because 1 is present in both intervals. So I have to check, we have to check continuity at the point x is equal to 1. So why we take x is equal to 1? Because I am telling again, because 1 is the breach number which is present in both the intervals. So at x is equal to 1, right hand side limit of the given function of the function when x greater than x tends to 1 plus means x greater than 1. So at x greater than 1, what function should be taken? Now, this function must be taken for x greater than 1. So the function is limit x tends to 1 plus function is x one minus of f of x is equal to when x tends to 1 minus means x less than 1. So at x less than 1, this function will be taken. Limit x tends to 1 minus the function is x square plus x plus 1. So putting the value of x, 1 square plus 1 is equal to 3. Now I have to find out the value of the given function at x is equal to 1. So at x is equal to 1, what function should be taken? Now at x is equal to 1 means in this interval the function is this. So f of 1 is equal to 1 square plus 1 is equal to 3. So these three values are equal. So that is why we can say that the function is continuous at the point x is equal to 1. So this is the answer for what the function is continuous at the point x is equal to 1 and 1 is the breach point because 1 is present in both intervals. Now I'm coming with another question, that is this. Discuss continuity and differentiability of the given function at x is equal to 0. So in this sum we have to apply the differentiability and continuity. So this is the combined sum in which we can apply, we can test both, means continuity and differentiability. So first of all, we check continuity at x is equal to 0. So x is equal to 0. So first of all, we rewrite the function. First of all, we rewrite the function. So f of x is equal to minus x. Why we take minus value of mod x? Because x less than 0. So minus x, that is why minus x is taken instead of mod x. So because for what condition? No, because x less than 0, that is why. E to the power minus 1 by x 4 by 2 minus e to the power minus 1 by x. So f of x is equal to 0 when x is equal to 0, because it is given. This value is given. And at x greater than 0, the function will be mod x is x, because x is positive. So x into 3 into e to the power 1 by x 4 by 2 minus e to the power 1 by x. So we arrange the function in this way first of all, then we will solve the question. So first of all, we have to check continuity at the point x is equal to 0. So at x is equal to 0, right hand side limit of the given of the function, the limit x tends to 0 plus, when x tends to 0 plus is taken. So f of x is equal to limit x tends to 0 plus x into 3 into e to the power 1 by x plus 4 by 2 into e to the power 1 by x. So we have to solve this limit. This based from this this question is based on limit sum of limit. So limit x tends to 0 plus x into, from numerator and denominator, e to the power e to the power 1 by x is divided from numerator and denominator. So that is why we have to multiply e to the power minus x to the numerator and to the denominator. So 3 plus 4 into e to the power minus 1 by x 2 into e to the power minus 1 by x equal to 1. So when x tends to 0 plus 1 by x, the value of 1 by x approaches plus infinity. So e to the power minus tends to 0. So the value will be 0 because x is 0, x tends to 0. So that is why total value will be 0. So right hand side limit of the function, the value of right hand side limit of the function is 0. So now checking at x tends to 0 minus, what will be the result? What will be the result? Let's see. So limit x tends to 0 minus, when x less than 0, then this function will be taken. So minus x into 3 into e to the power minus 1 by x plus 4 by 2 minus e to the power minus 1 by x. So same way what we have done previous, in that way minus x into 3, in this case e to the power 1 by x should be multiplied by e to the power 1 by x. So putting the value of x is equal to 0 and the value at x is equal to 0 of the function is 0. So these three values are also same. That is why we can say that the function is continuous at the given point x is equal to 0. So at x is equal to 0, the function is continuous. Now we have to check differentiability at the function, differentiability of the function at the point x is equal to 0. So for checking differentiability at any point, we have to find out right hand side derivative of the function that point at that point and left hand side of the function at that particular point. So f dash 0 plus is equal to limit h tends to 0 plus f of 0 plus h minus f of 0 by h. So x tends to, sorry, x greater than 0 So x minus 0 greater than 0. So this is taken as, this is assumed as small h. So the function will be taken in this case, this one. So limit h tends to 0 plus f of h. So we have to put h instead of x. So h into 3 into e to the power 1 by, sorry, 1 by h plus 4 2 into e to the power 1 by h. So this also be solved in the same manner that I have done in case of checking continuity. So four into e to the power minus 1 by h, 2 into e to the power minus 1 by h, 1. So sorry, extremely sorry. H will be eliminated. E to the power minus 1 by h minus 1. So the limiting value of this function is minus 3 because x tends to, because h tends to 0 plus then 1 by h tends to plus infinity, therefore e to the power minus 1 by h tends to 0. So the limiting value of this function is minus 3. So now I have to we have to check another point. Sorry, we have to find out the value of left hand side derivative. So 0 minus, so limit h tends to 0 minus. In this case, we have to take this function. So minus h minus 1 by h plus 4, 2 minus e to the power minus 1 by h minus 0, because f of 0 means 0 by h. So h will be cancelled out from numerator and denominator. So h tends to 0 minus tends to 0 minus e to the power minus
Let's continue. This is a problem on differentiation. So the given function is y equals to root over sine x square. We have to differentiate this function with respect to x. Let's do that. Dy by dx equals to d dx of sine x square whole to the power 1 by 2, because square root we can take square root as to the power 1 by 2. Now dy by dx equals to, so we will apply chain rule in this sum. First 1 by 2 will come in front, and then it will be sine x square whole to the power 1 minus 1 by 2. But we have to differentiate the function inside this bracket, that is d dx of sine x square. Now let's proceed. 1 by 2, and it will become sine x square to the power minus 1 by 2. And after doing the differentiation of sine x, we will get cos x square, and then we will have to differentiate further x square. Let's do the remaining sum in this side. Dy by dx equals to, it will be 1 by 2 sine x square to the power minus 1 by 2 into cos x square into 2x, because differentiation of x square with respect to x, it will give 2x. 2 and 2 will be cancelled out, so ultimately we will get 1 by root over of sine x square into cos x square into x. So the final result is x cos x square by root over of sine x square. So this is the sum. Let's proceed. This is a logarithmic function, and we will do logarithmic differentiation. So the function is y equals to log 1 plus sin x by 1 minus sin x. Let's first modify this portion. We know log m by n equals to log m minus log n. We will apply this formula first. So it will become log 1 plus sin x minus log 1 minus sin x. Now we will perform differentiation on this sum. So dy by dx equals to d dx of log 1 plus sin x minus d dx of 1 minus sin x. We will again apply chain rule on this sum. Log 1 minus sin x. So we know d dx of logarithmic function, derivative of logarithmic function is 1 by x. So it will be 1 by 1 plus sin x into further derivative of 1 plus sin x minus 1 by 1 minus sin x into d dx of 1 minus sin x. This is a bit larger sum. Let's proceed. So here 1 by 1 plus sin x into derivative of 1, that is a constant function or constant number, so it will be 0, and derivative of sin x, it will be cos x minus 1 by 1 minus sin x into derivative of 1, it will be 0, and derivative of minus sin x, it will give minus cos x. So ultimately we will get cos x by 1 plus sin x plus this minus and minus will be multiplied and it will get plus, and cos x by 1 minus sin x. Now we will add these fractions and we will get 1 plus sin x into 1 minus sin x, and this will be cos x into 1 minus sin x plus cos x into 1 plus sin x. Here, so cos x into 1, it will give out cos x minus cos x into sin x, we will get sin x cos x, and this will be plus cos x minus sin x plus, sorry, plus sin x cos x, and the denominator will be a plus b into a minus b, that is the formula of a square minus b square. So denominator will be 1 minus sin square x. Here this and this will be we have already proved this one. So proved. Now you are given two sums. One is in the form of normal sum, but these two are very short answer type sums. Answer the find out the answer and comment in comment section. Thank you. We'll take a very little short break.
Hello students. So I'm coming back again with this two problem. So these two problem based on MCQ type. These two questions are based on MCQ type question. So for the first question, we have to detect the point. We have to detect the point of discontinuity of the function. The function is f of x is equal to x plus 2 by 2x square minus x minus 1. So first of all, we have to resolve the denominator into factors. So 2x square minus x minus 1 is equal to 2. With the help of middle term break, so 2x plus x minus 1. So 2x x minus 1. So x minus 1 into 2x plus 1. So f of x x minus x minus 1 is equal to x plus 2 x minus 1 into 2x plus 1. So first of all, we have to find out the value, the point at which the given function is undefined. So you can see that at x is equal to 1, the function will be undefined, and for x is equal to minus half, also function will be undefined. So minus half to 1. So this is the right answer. Okay. So now for this question, we have to find out the value of k for which the given function is continuous at x is equal to 2. So it is given that the function is continuous at which point? At what point? Now x is equal to 2, the given the function is continuous. Limit x tends to 2 plus, then this function will be taken, so x minus 1, so therefore 2 minus 1 is equal to 1, and limit x tends to 2 minus, then the function will be taken, this function will be taken, so k into x plus 5 is equal to 2k plus 5, and f of 2 is equal to 2k plus 5. So since, sorry, since the function is continuous at the given point x is equal to 2, that is why these three values must be equal. So 2k plus 5 is equal to 1. So value of k should be minus 4 by 2 is equal to minus 2. So minus 2 is the answer, required answer. So differentiate tan inverse root over of 1 plus x minus root over of 1 minus x by root over of 1 plus x plus root over of 1 minus x with respect to the function cos inverse x by 1 plus x square. So let u is equal to tan inverse so let us take let us assume x is equal to sine theta. So then tan inverse root over of instead of 1 we can put cos square theta by 2 plus sine square theta by 2 plus x means sine theta. Sine theta means using the submultiple formula 2 sine theta by 2 into cos theta by 2 minus this can be done in the same way. So cos square theta by 2 plus sine square theta by 2 minus 2 cos theta by 2 into sine theta by 2 by cos square theta by 2 plus sine square theta by 2 plus 2 sine theta by 2 into cos theta by 2 plus cos square theta by 2 plus sine square theta by 2 minus 2 cos theta by 2 into sine theta by 2. So tan inverse this means a plus b whole square formula applying. So cos theta by 2 plus sine theta by 2 theta by 2 whole square minus cos theta by 2 minus sine theta by 2 whole square root over of cos theta by 2 plus sine theta by 2 whole square plus root over of cos theta by 2 minus sine theta by 2 whole square. So tan inverse cos theta by 2 plus sine theta by 2 minus cos theta by 2 minus sine theta by 2 by cos theta by 2 plus sine theta by 2 minus plus cos theta by 2 minus sine theta by 2. So cos theta will be eliminated from here. Sine theta will be eliminated. So tan inverse sine theta by tan inverse plus okay. So now sine theta by 2 by 2 cos theta by 2. 2 cancel out. So tan inverse tan theta by 2, that is meant theta by 2 using the formula of inverse trigonometric function, that is tan inverse of tan theta is equal to theta is equal to theta. So u is equal to theta by 2 is equal to half into theta is equal to what we assume, x is equal to sine theta. So theta is equal to sine inverse. This is also, this formula also belong to trigonometric inverse trigonometric function. So sine inverse x. So now differentiating on both sides, on with respect to x. So ddx of u is equal to half into ddx of, so half into ddx of sine inverse x. The formula of sine inverse x, 1 by root over of 1 minus x square. So now let let so pi by 2 minus tan inverse, this is the formula, cot inverse x plus tan inverse x is equal to pi by 2. So from using this formula we can write cot inverse 2x by 1 minus x square is equal to pi by 2 tan inverse pi by 2 is minus tan inverse 2x by 1 minus x square means 2 tan inverse x. This is also formula, belongs to inverse trigonometric function. So differentiating on both sides with respect to x is equal to ddx of pi by 2 means 0 minus 2 into ddx of tan inverse x means 1 by 1 plus x square. So So we have to find out the derivative of this function with respect to this function. So du by dz. So du by dx, dz by dx is equal to du by dx means 1 by 2 into root over 1 minus x square, and dz by dx means minus 2. So 1 by find out the dy dx at x is equal to 1 and the function is this. So since the power is variable, so if the base is variable and also the power is variable, in that case we have to take log on both sides because there is no formula of this function. Taking log to the base, we should take Neperian logarithm. So that is log to the base e on both sides. So log is equal to log. So y into log x. This is the formula from logarithm. So that is x into log. So y into log x is equal to x minus 1, x minus y, sorry, into log e. Log e means, log e to the base e means, this is also formula from logarithm. So that is 1. I can put x minus y is equal to x minus y into 1 means x minus y. So differentiating on both sides with respect to x, y into using chain rule, differentiating on both sides with respect to x using chain rule. Over y by x into log x plus y by x is equal to 1. So y by x to be taken as common is equal to 1. So y by x is equal to 1 by log x plus 1. So I have to put the value over here. So 1 minus log x plus 1. So simple. So 1 log x plus 1 minus 1 by log x plus 1. So 1 will be eliminated. So dy by dx is equal to log x by log x plus 1 whole square. This will be coming over here. So log x plus 1 into log x plus 1 is log x plus 2 whole square. So putting the value of x, x is equal to 1 log 1 by log 1 plus 1 whole square. So log 1 means 0. 0 by 1 means 0. So the required answer of the given function is 0. So differentiating on both sides with respect to x, dy by dx is equal to dx of sine inverse x whole square plus k into dx of sine inverse x. So dx of sine inverse x is equal to 1 by inverse 1 minus x square. So it is equal to 2 into using chain rule 2 sine inverse x into sine dx of sine inverse x means 1 by 1 minus x square plus k into 1 by 1 minus x square. So multiplying on both sides by e to the power of 1 minus x square, that is meant to the power 1 minus x square into dy by dx is equal to 2 sine inverse x plus k. So again, differentiating on both sides with respect to x. So using product of the function, using the product rule of the function. So to the power of 1 minus x square into dx of dy by dx means d2y by dx2 plus dy by dx into differentiation of to the power 1 minus x square means 1 by 2 1 minus x square into minus 2x is equal to 2 by to the power of 1 minus x square plus 0 because in constant the dx of k means 0. So again multiplying on both sides by to the power of 1 minus x square. So 1 minus x square into d2y dx2 plus half into sorry to be eliminated minus to the power of 1 minus x will be cancelled out. Into x is the answer 2. So hence it is proved. Okay, this is all about the topic and our program. So stay tuned.
Okay, thank you, sir. Very nice session. And lots of information was there. Hopefully, you all liked it. And we will have our mentorship, which is coming from 1st November. Please join us, have our mentorship, and do better result in books. Thank you. Stay tuned. Our next session is for Chemistry Live.